Hey guys, so in the first half of the year we spent a lot of time looking at linear functions when the degree of x is raised to the first power, and we also spent a lot of time looking at quadratic functions, so y equals ax squared plus bx plus c when the degree of dx is raised to the second power. So in this unit we're going to start looking at polynomials, where we have polynomials with degrees raised to the third power, a cubic function, the fourth power, a quartic function. So standard form of a polynomial, which looks super complicated, is just very simple. It's just when you write it in order, in descending order from highest degree to lowest degree. So just like standard form in a quadratic, the x squared goes first. If x cubed is the term with the highest degree, then that one goes first. And so in the chart on the right, we're just going to extend our knowledge based on what we know. When the degree is 0, we call that a constant. So x to the 0 power, and here's an example, x to the 0 power is 1, and you don't see the x at all. So this is a constant function which graphs a horizontal line. When the degree is 1, we call that a linear function. So you can see that it's x to the first power. And the function that we have is a line, a linear function, 5x minus 7. When the degree is raised to the second power, so 2x squared, we call that a quadratic, and we know that's the shape of a parabola. And then we've got when the degree is x to the third power, okay, we call that a cubic, and we know that that's like a sideways S shape. And notice that in the cubic, you also have the x squared and you have the x term as well, but the term with the highest degree is x cubed, and so we call that a cubic. And if the highest degree term is raised to the fourth power, we call that a quartic. And if it's raised to the fifth power, we call that a quintic. And that's just all the special names. Anything 6th power or more, so x to the 6, x to the 7, we just say it's a 6th degree polynomial or a 7th degree polynomial. Alright, so in this section we're going to look at adding and subtracting, and then tomorrow you're going to look at multiplying polynomials, and Wednesday you're going to look at dividing polynomials. So that's our week, looking at how to do add, subtract, multiply, divide on polynomials. So adding and subtracting is very easy. Polynomials just means it's many terms, okay, and all it is it's the same as adding and subtracting quadratic expressions. We're just going to combine like terms when we can. So in here, we've got 3 polynomial expressions. Polynomial just means many terms. So a binomial is a polynomial. It's got 2 terms. Okay, quadratic is a polynomial. Cubic is a polynomial. X to any power is a polynomial. So we've got 3 of them. 2x squared plus 6y plus 3x, y. 3x squared minus 5x minus x, and 6xy plus 5, and we want to add them. So if I want to add these 3 polynomials, all we're doing is combining like terms. And so let's go ahead and combine like terms. I've got 2x squared, and I've got 3x squared, and those I can combine to make 5x squared. Okay, and then I've got the 3xy, the positive 3xy, and I have a negative 5xy and a positive 6xy that I can combine. And notice how I circled the sign in front of that term, because that sign goes with that term. So 3xy minus 5xy, that's going to give me negative 2xy, plus 6xy is going to give me positive 4xy. Okay, 3 minus 5 plus 6, there's 4 of them left. And then we've got 6y that I can't combine with anything. There's no like terms. And then we've got the negative 1x. Again, I can't combine that with anything. And my constant with no variable, the 5, that I can't combine with anything. So this is it. 5x squared plus 4xy plus 6y minus x plus 5 is my polynomial after I add it. And we usually try to write it in the standard form when we write, so if the highest degree term first, the x squared goes first. So that's one way to add and subtract. Okay, another way that you might like, I'm going to show you, entirely up to you whether you want to do it that way or not, is sometimes people find it helpful to add or subtract vertically. It's kind of like when you could do 3 plus 5 horizontally, or you could do 3 plus 5 vertically. Okay, either is fine. So for long and complicated polynomials, sometimes it's helpful to add vertically. So I'm going to rewrite these. 2x squared plus 6y plus 3xy, and then when I add the other two polynomials, I'm just going to line it up with the like terms. So 3x squared and negative 5xy, I'm going to line it up with this 3xy minus x, that's a different term that I can't combine, and plus the 6xy and plus the 5, and then I can go ahead and add these. So that's going to give me 5x squared and 6y and 3 minus 5 plus 6, that's going to give me 4xy minus x plus 5, and we get the exact same thing, just rearranged a little bit differently. Okay, so either way is fine, entirely up to you, and you just want to make sure that you do put your final answer in standard form if you can. Okay, so adding, combining like terms. Subtracting is also just combining like terms, but one thing you have to be careful when you're subtracting is that you need to be sure to distribute the negative to every single term in the expression that you're subtracting. So in example 2, we have 5y squared plus 2xy minus 9, and then we're going to subtract this whole expression. Subtract 2y squared plus and subtract the positive 2xy and subtract the negative 3. And so because I'm subtracting the whole expression, I want to make sure that I distribute that negative through. So I'm going to rewrite it as 5y squared plus 2xy minus 9. And then I need to subtract 2y squared. And I need to subtract 2xy. And I need to subtract a negative 3, which becomes a positive 3. So be sure to distribute that negative because you're subtracting every single term. And then from there, we're going to again go ahead and combine like terms. So looks like I've got 5y squared and negative 2y squared. I'm going to combine to 3y squared. And then I've got positive 2xy and negative 2xy, which adds to 0, so they cancel out. And then finally I got negative 9 and positive 3. That adds to give me negative 6. And so this is my final answer, 3y squared minus 6. Okay, sometimes in problems it's in words, and so you have to be careful to read it correctly. So I'm going to give you a little subtraction problem in words. It says subtract 3x cubed plus 2x squared minus x plus 7 from 8x cubed minus x squared minus 5x plus 1. So this is what you're subtracting from. Okay, so I'm going to take that and I can do this one vertically, entirely up to you which way you like to do it. So 8x cubed minus x squared minus 5x plus 1, I'm going to subtract away the 3x squared and the 2 plus 2x squared minus x plus 7, and I'm subtracting all of these. So I'm going to distribute that negative through. I'm going to subtract the 3x squared, I'm going to subtract the 2x squared, I'm going to subtract negative x, which turns it positive, and I'm going to subtract 7. So from there, I've got, this should be a cubed, sorry. So 8x cubed minus 3x cubed is 5x cubed. Negative 1x squared, that's an invisible 1. minus 2x squared is negative 3x squared. Negative 5x plus 1x is negative 4x. And 1 minus 7 is negative 6. And here it is, okay? And if you like subtracting horizontally, you can do the same thing. And you would just do 3x cubed plus 2. Oh, that's not what I'm starting with. My fault. 8x cubed minus x squared minus 5x plus 1, and then subtract away the second expression, so minus 3x cubed minus 2x squared minus negative x, so plus x, and then minus 7. So just remember to distribute the negative, and then you're good to go. And then combine like terms, all right? So adding and subtracting, combine like terms. Remember, you're not doing anything with the exponents for the x. You're just adding and subtracting, combining like terms. And be careful with your positives and negatives. And when you subtract, be extra careful and remember to distribute your negative.